Hello everyone, we are from group B6 and we did the experiment number 5, which is the clumping film evaporator. My name is Divrananda and I will be doing the introduction for the CFE, which is also known as the clumping film evaporator. Evaporation process is when the vapor is removed from a much more boiling aqueous solution. In majority of the cases, the separation, which is also known as evaporation, is where the water is removed from a much more boiling aqueous solution. The apparatus that performs the evaporation process is also known as the evaporator. Many industries such as sugar industries, dairy industries and also chemical industries use evaporator for the removal of water vapor and make the solution much more concentrated. The clumping film evaporator, or also known as the CFE, is a special type of evaporator which reduces the heat transfer coefficient and also a short residence time for the solution to be evaporated. This CFE is usually operated at a vacuum condition where this vacuum condition allows the solution to be evaporated at a lower boiling temperature and also increasing the heat flux. The CFE is usually designed in a way that it can be operated as a batch or a continuous evaporator. This CFE is designed in such a way that it can be used for the study of concentration of the sensitive solutions such as milk, fruit juices and so on.
Before we conduct the experiment, there are a few safety precautions that you need to follow, which is the first one, wear the safety helmet, and the second one, wear properly your lab coat, and the third one, wear covered rubber shoes. This is to prevent from any damage or injuries which can harm your body.
Next, we proceed to the experimental procedure of this clumping film evaporator. This experiment consists of two parts. The first one, which is to measure the effect of the evaporator pressure, and the second one is to measure the effect of evaporator feed level. Step 1 is we turn on the feed pump in order to regulate the potassium manganate in the feed tank. The second part is we need to increase the level of the potassium manganate to 25 cm using the valve V6. Once the level of the potassium manganate has been reached at 25 cm, the steam valve is open and the purge valve is closed at the same time. As a step of caution, make sure you wear your gloves since the steam valve is hot. The steam valve is open and the purge valve is closed simultaneously. At the same time, someone needs to start the timer. After the timer has been started, observe the behavior of the potassium manganate in the evaporator column. Once the potassium manganate has produced their first bubble, the time is recorded and measured. After that, measure also the time taken for the potassium manganate in the evaporator to boil. After the two of the time has been taken, you need to wait for around 20 minutes before the next step. After 20 minutes, the steam valve is closed and the purge valve is open. After that, we need to take 3 samples, which are the evaporator sample, the condensate and the concentrate. The condensate can be taken directly from the receiver tank, which is by using the valve B12. Next is we need to take the concentrate sample. The concentrate sample is located in the upper tank. In order for it to collect it in the concentrate tank, we need to open the valve B7 and also closing the valve B9 in order for the concentrate to flow down into the inlet pump. To push the concentrate into the concentrate tank, we need to use a pump. When we open the pump, make sure that the valve B7 closed and the valve B9 is open. And after all the concentrate are pushed into the tank, close V9 and close the pump as well. And then you can just take samples out for it. And for the evaporator sample, put a beaker under the valve and the collector and take the samples. After all the samples have been taken out, using a measuring cylinder, measure the volume of each sample. After the volume has been measured, gently put all the samples into a small beaker and pour the remaining of the samples into the feed tank. The refractive index of these 3 samples are measured and recorded as well.
Hi everyone, I am Sunny. Now, I'm going to present to you the result of our experiment. In experiment 1, our objective is to find the effect of evaporation pressure on evaporation rate. As a reminder, in this experiment, we need to set the feed level at 25 cm and we vary the pressure from atmospheric pressure, which is 760 mmHg, to negative 200 mmHg, negative 400 mmHg, and negative 600 mmHg. As you can refer to the graph on my left hand side, you can see that as the pressure decreases, the time of appearance of first bubbles and multiple bubbles also decreases. This is because the vapor pressure in the system decreases, and causing the boiling point in the system also decreases. Thus, we can conclude that as the pressure decreases, the vapor pressure in the system also will decreases, causing a higher evaporation rate of the system. In experiment 2, this is a graph of time taken versus feed level. When we increase the feed level, the volume inside the evaporator will increase. Thus, the time taken to form the first bubbles and multiple bubbles will increases because the longer time is needed to vaporize the vapor from the evaporator. This is a graph of concentration versus feed level. When we increase the feed level, the concentration of evaporate will decreases due to the slow evaporation rate. This is because a longer time is needed to vaporize the vapor from the solution when we increase the feed level. The concentration for condensate and concentrate are the same because both of them have the same RI index, which is 1.33297. Thus, the concentration for condensate and concentrate are the same. On my left, this is the graph of volume versus feed level. When we increase the feed level, the evaporation rate will decreases. Thus, the amount of evaporate retained in the system will increase when we increase the feed level. Theoretically, the amount of condensate and concentrate should decreases when we increase the feed level because a longer time is needed to evaporate the vapor from the evaporator. However, due to some error exists in the experiment, the concentrate volume increases as shown in the graph. In the other hand, the amount of condensate shows the correct path as according to the graph because when we increase the feed level, the amount of condensate will decreases. In the other hand, we also calculate the heat efficiency of experiment 1. Throughout all the variation of pressure in this experiment, we found that the HEPP remained the same as 100% because the concentration of condensate and concentrate are the same. Next, from the refractive index we obtained in the experiment, we convert the refractive index into concentration. On my right, this is the graph of concentration versus pressure. When we decrease the pressure, the evaporation rate will increase. Thus, more vapor will be vaporized from the evaporate into condensate and concentrate. Thus, the concentration of evaporate will increase because the potassium permanganate inside become more concentrated. The concentrate and condensate we obtain in these experiments is actually in water vapor form, which they both have the same refractive index, which is 1.33297. That is why the concentration of concentrate and condensate shows a straight line in the concentration graph,
because the concentration of water is the same. From the previous graph, we know that when the pressure decreases, the evaporate rate will increases. Thus, the amount of evaporate will be lesser. Therefore, the amount of concentrate and condensate will increase because more vapor is vaporized from the evaporate to the condensate and concentrate. When we compare the volume of concentrate and the volume of condensate, we found that the volume of concentrate is actually higher than the volume of condensate because of the turbulence flow in the system.
Now I will be doing the errors and recommendation part. First, to measure the correct value of the volume of the condensate, we have to make sure that the condensate solution is transferred fully to the receiver. This can be done by allowing the condensate solution to the inlet pump and then being pumped back to the receiver completely for the solutions to be taken. Experiment part 2, we are required to maintain a stable pressure as preferred. So to do this, one have to always observe the pressure gauge and toggle the on and off button to maintain the pressure at the required condition. After collecting the samples of the evaporate, concentrate and condensate, we have to measure the volume. While measuring the volume, we have to maintain our eye level to the meniscus line of the cylinder. After collecting the samples, we are required to get the refractive index through the refractometer. To get the accurate reading, we have to make sure the refractometer is cleaned completely with distilled water. Both parts of the experiment, we are required to record the time taken of the first boiling of the first bubble and also the multiple bubbles. While recording the time taken for the first bubble and also the multiple bubble, the same person should observe and record the time to make sure there are no different judgments in the later part of the experiments.
Hi, my name is Diana Zara and I'll be explaining the conclusion of our experiment. For the first experiment, which is to study the evaporator pressure on the evaporation rate, we can conclude that the lower the pressure, the higher the evaporation rate. This is because the liquid will boil at temperature where its vapor pressure is equal to the pressure of the gas above it. When the pressure of the gas above liquid decreases, the time taken for the solution to reach its boiling temperature will be faster. Thus, the evaporation rate will be faster too. And for the second experiment, which is to study the evaporator feed level on the rate of evaporation, we can conclude that as the feed level increases, the evaporation rate will be decreasing. This is because as the volume increases, more heat required to increase the temperature of the solution to reach its boiling temperature, and thus it causes the evaporation rate lower. Climbing film evaporator is used heavily in the paper industry, which is to concentrate like liquor, and also it is used in the food industry, which is to condense milk, and not to forget the pharmaceutical industry for the crystallization of the supplementary pills, drugs, and antibiotics. There are a few limitations to this climbing film evaporator, and one of the solutions to improve the product quality is to use falling film evaporator. Here are a few comparisons between climbing film evaporator and falling film evaporator. For the climbing film evaporator, it has inefficient heat transfer at low temperature differences, while falling film evaporator has efficient heat transfer at all temperature differences. And for the second comparison, we can compare that climbing film evaporator has longer residence time, while falling film evaporator has shorter residence time. If it has shorter residence time, it can improve the product quality. And the third comparison is climbing film evaporator is more sensitive to solid loading, while polyfilm evaporator is more sensitive to liquid distribution. This is because it can make use of gravity to help the flow of the solution in the tubes.